Hello class, welcome to Algebra Lesson 9-7, which is all about solving systems involving linear and quadratic equations. By the end of this lesson, you should be able to solve a system with linear and quadratic equations. So just a quick recap, systems of equations is when you have two or more equations put together. A few chapters back, we talked about systems of equations, where you would graph multiple lines on the same graph and tell me where do those lines intersect. And then we practiced graphing systems of linear inequalities. So the ones that had that shading, and then you would tell me where their shaded regions overlapped. Well, today we are going to practice graphing or solving systems of linear and quadratic equations. That means that we're going to be looking at graphs that have a parabola on them, and not just a parabola, but a straight line. Okay, and then you're going to tell me where do those graphs intersect. Okay, so the first thing that we're going to do is look at all right, example 1, use linear quadratic systems of equations. So let's first talk about why are the solutions of a linear quadratic system of equations related to the solutions of a quadratic equation. So if we think back to solutions of quadratic equations, remember it's possible to have two solutions. That's what we practice solving with the discriminant, one solution or zero solutions. Remember those solutions for a quadratic equation tell you where it crosses the x-axis, which if you think about it, the x-axis is a straight line, right? It's a straight line that's just always in one location. And the quadratic equation may or may not cross it 0, 1, or 2 times. So a linear quadratic system of equations is that same idea, where you have that parabola and then a line that may cross it, a line that may not cross it. So if you look at a linear quadratic system of equations, we have y equals mx plus b. That's our slope-intercept form from way back in chapter 2. That's when we started talking about that this year. And then our y equals ax squared plus bx plus c. Hopefully this is becoming pretty familiar to you by now. And if you notice, that slope-intercept form is the same as the last two terms of our quadratic equation. That's how these are related, and that's why those solutions will be just kind of like what we talked about, where you can have no solution. If you notice, the green parabola never touches the purple line. One solution where it just crosses at one little spot, or two solutions where it crosses in two different locations for that red line that's like way up there and then down here. Okay, so when you look at a graph, you're telling me how many times is it crossing, where is it crossing, and then your answer is those ordered pairs. All right, if you think about this one, how many solutions would the system of equations below have? So you have y equals x squared. So I recommend just sketch out a graph. What does y equals x or y equals x squared look like? Another thing you can do, you can use a website called Desmos if you're having a hard time visualizing these equations. You can use desmos.com. So go ahead, either graph it or check out Desmos and see how many solutions does this system of equations have. Good luck. All right, hopefully you were able to figure out that there would be two solutions. It would cross at 0, 0, and it would also cross at 1, 1. This is a picture I took of Desmos just to give you a nice visual of what that graph might look like. Not what it might look like, what it actually looks like, okay? So I'll have you be looking at graphs. I'm not going to make you actually graph them on your test, but I'm going to have you kind of interpret your graphs, okay? All right, example 2, solve systems of equations using elimination. So elimination is where we would add or subtract equations together. So I'm going to start by just rewriting. We have y equals x squared minus 6x plus 8. And then I'm going to rewrite the second one. Y equals, I'm going to put that 2x under the other x term, so they're stacked on top of each other, and that minus 4 under the 8, so they're again stacked on top of each other. And then what I'm going to do is I'm going to subtract these two equations because I want my y's to go away. I want those to become 0. So I'm always going to subtract the two equations, and I'm always personally going to subtract the linear equation from the quadratic. Okay, so then I have x, so y minus y is 0, x squared minus, and then there's nothing here. So that's like saying 0x squared. So x squared minus 0 is just x squared. And then I have negative 6 minus a positive 2. That becomes negative 8x. And then I have 8 minus negative 4. That becomes plus 12. Okay, so now from here, I have a quadratic formula that I've been practicing solving all chapter. I personally, just from my experience, can see, hey, these numbers are kind of related to each other, and I bet I can just factor it. So I have a positive here, negative here. That means that they're both negatives. Negative 1 times negative 12 is 12, but does not add up to negative 8. Negative 2 and negative 6, however, multiplies to a positive 12 and adds to that negative 8. So I'm going to say 0 equals x minus 2, x minus 6, and then I'm going to keep solving. I'm going to say x minus 2 equals 0, x minus 6 equals 0, so x equals 2 or x equals 6. And then you're not quite done yet because we're trying to find an ordered pair. So you're going to take these x values once you have them and plug them back into your linear equation. So I'm going to say y equals 2 times 2 minus 4. So y equals 2 times 2 is 4 minus 4 is 0. So this solution would be 2 comma 0. And then over here, I would say y equals 2 times 6 minus 4, or y equals 12 minus 4, which is 8. So my ordered pair over here would be 6 comma 8. And then I would be all done with this problem. Okay, so first I rewrote it so things were stacked on top of each other. I subtracted to get rid of my y value, and then I factored in order to get my solution. Sometimes you'll factor, sometimes you will not factor, but you will use a square root to solve, or you'll use quadratic formula to solve. But usually, or like in this example, I was able to just factor. All right, now this is one for you to solve. The only thing I'm going to do before I let you solve this is I'm going to rewrite it. I'm going to say y equals negative x squared plus 4x plus 2. And then I'm going to say y equals, and then instead of writing 2 minus x, I'm going to put that positive 2 right over there. And then it's a negative x, so I'm going to put negative x. And then I'm going to put my 0x squared in as a placeholder. All right, now go ahead and solve this system using elimination. Good luck. All right, for this problem, hopefully your work looks a little like what I have there. And then you would have the two ordered pairs 0, 2, and then 5, negative 3. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. All right, example 3, solve systems using substitution. We have a phone company launches the sale of 2 phones in the same week. The phone on the right is an upgraded version of the other phone. During what week are the sales projected to be the same for both phones in thousands? What will the weekly sales of each phone be that week? So we have y equals negative 2x squared plus 60x for the phone on the left. Then we have y equals 20x for our upgraded phone right over here. Okay. Since it says we're going to use substitution, let's remember when we have a y equals and a y equals, that means that I get to just set it up where I get rid of the y's and I set the two equations equal to each other. Then I'm going to solve for x. So I'm going to subtract that x over, so that way I have my x terms, my regular x terms, on one side. So I have negative 2x squared plus 40x, And then if I look at this, I see, hey, those have a 2x in common, but I also don't like to have my x squared term to be negative. So I'm going to pull out a negative 2x. So that way this first term becomes a positive x, then minus 20. Now I solve just like what I've been doing. I say negative 2x equals 0, and then I have x minus 20 equals 0. So if I divide this, x equals 0, or x equals, if I add, 20. And if we think about that, x equals 0 represents the start of the sale of the two phones, right? So obviously the number of phones sold would be equal at this point because they're both being released at the same time. So we don't really need to worry about that in this situation, in this real world scenario, because we don't care that they're at the same starting point. But we do care about the 20th week of sales. And so what I'm going to do is I'm going to say I'm going to plug 20 in for x. So I have 20 times 20. So y equals 400, and that 400 represents the sale of phones in thousands. So we have in the 20th week, the company has sold 400,000 phones. So that would be my solution to this problem. Okay, so I used substitution. I just took my 20x, plugged it in right over there, and then solved. It's really up to you how you want to do, whether you choose elimination or substitution. Honestly, they'll both work, okay? If you have questions about that, please be sure to ask for some help. And then here is your concept summary for today's lesson. Feel free to take a screenshot of that if you would like. Otherwise, if you have any questions, reach out for help. I'm happy to help you. Have a great day.